Here is a regular octagon with two vertices joined to make the line AB. Join two other vertices to draw one line that is parallel to the line AB. So we need to remember an octagon is an 8-sided shape. Vertices are the corners or the pointy bits of the shape, and parallel lines are like train tracks in that they would go on forever if we extended them without them ever crossing. So if we take the line AB, we can see that we could have this vertex joined to this vertex here, so our lines are parallel, or the other possible solution is to have this vertex here joined to this vertex here. Here is the octagon again. Join two vertices to draw one line that is perpendicular to the line AB. So perpendicular is the opposite to parallel. With perpendicular lines, if we extended them, they would cross at 90-degree angles. So this line here is perpendicular because that creates 4 right angles. We could also have this line here or this line here. And it's easier to see right angles, so easier to see perpendicular lines, if we just turn our page slightly to make the line that we have horizontal, and then we can see that if we draw a line here, that's perpendicular because it creates 4 right angles. This line here is also perpendicular, and so is this line here. Here is a number chart. Every third number in the chart has a circle on it. So we can see the numbers circled are all numbers that are in the 3 times table, so multiples of 3. The chart continues in the same way. Here is another row in the chart. Draw the missing circles. So remember, the circles need to be around numbers that are multiples of 3, numbers in the 3 times table. So to see whether a number is a multiple of 3, we can divide it by 3. And then if we don't get a remainder, then we know that it is a multiple. So 72 divided by 3 is 24. That means 24 times 3 is 72. So 72 is in the 3 times table. So we need to circle 72. And if we count on 3, we can see that we'll also need to circle 75. That's a multiple of 3 as well, because when we divide it by 3, we don't get a remainder, we get a whole number. So we can see here that 25 times 3 is 75. Now, will the number 1003 have a circle on it? Explain how you know. Well, to see whether the number 1003 needs to be circled, we need to find out whether it's a multiple of 3. Now, if we divide 1003 by 3, we get 334, remainder 1. So because we get a remainder, we know that 1003 is not a multiple of 3. So our answer is no. Multiples of 3 are circled. 1003 is not a multiple of 3 because dividing it by 3 gives a remainder. Alfie has some rectangles, so we can see that the shorter sides are 3 centimeters and the longer sides 8 centimeters. He makes this shape using 3 of the rectangles. What is the perimeter of Alfie's shape? So we need to remember that the perimeter is the distance around the outside of the shape. So we can write the lengths of the sides we know. We know that the longer sides of the rectangles are 8 centimeters and the shorter sides 3 centimeters. So we can write these values on our shape. But we have these two lengths here, which we don't know, but which we can work out. Notice here, we have the shorter end of a rectangle, so that's 3 centimeters, and we have the longer length here, which is 8 centimeters. So now something plus 3 has the same length as 8. So we know that these lengths must be 5 because 5 plus 3 is 8. And we know and we can see that the lengths are the same. So we have 4 eighths, that's 32. We have 4 threes, so that's 12. And we have 2 fives, so that's 10. So if we add up all the lengths that we've written, so the lengths around the outside of the shape, we get 54 centimetres, so that's our perimeter. Notice when we're finding the perimeter, we don't write or we don't add these lengths here because this length here is not on the outside of a shape and the perimeter is the distance around the outside. The shaded shape is a square. What are the coordinates of A and B? Well, if we look at point A, we know the first coordinate we write is the x-coordinate. So if we go down, we can see that that's in line with this point here, where the x-coordinate is 7. So we can write 7 on our coordinate grid. So A has an x-coordinate of 7. We'll come back to the y-coordinate in a moment, but for now let's look at point B. If we go down, we can see that that's in line with this point here, where the x-coordinate is 17. So we can write 17 on our grid, and we know that the x-coordinate of B is 17. But how can we find what the y-coordinate will be? Well, here we have to look at the question carefully. They've told us that the shaded shape is a square, and we know that squares have sides of the same length. So we can work out that the length of the square, the length of each side, must be 10, because the difference from 7 to 17 is 10. And because the sides of a square are the same length, we have 10 here as well. So we know that the y-coordinate here is 3, because the y-coordinate for this point is 3 and for this point is 3 as well. So if we go up 10, we get 13 as our y-coordinate for A and B, because 3 plus 10 is 13. So the coordinates for point A are 7, 13, and the coordinates for B are 17, 13. 364 is a multiple of 7, but not a multiple of 3. 384 is a multiple of 3, but not a multiple of 7. Find a number between 364 and 384 that is both a multiple of 7 and a multiple of 3. So remember, a multiple of a number is a number in that number's times table. So if it's a multiple, you can divide without getting a remainder. So we're told that 364 is a multiple of 7. So if we add another 7, that will take us to the next multiple of 7. Because remember, with multiplication, what we really have is repeated addition. So 364 plus 7 is 371. So that must be a multiple of 7 as well. But is it a multiple of 3? Well, to find out, we need to divide. And remember, if we don't get a remainder, then it is a multiple of 3 as well. We can divide using short division, but because we get a remainder, 371 is not a multiple of 3. So we need to try something else. If we add another 7 to 371, that gives us 378. So notice, because we started with a number that we know is a multiple of 7, and we've added 7, then added 7 again, we still have a multiple of 7. But is 378 a multiple of 3? Well, let's divide to find out. We can do that using short division, and we get 126. So, because we don't get a remainder, we know that it is a multiple of 3 as well. And let's just check that it's a multiple of 7, just in case we've made a mistake when we were adding 7. When we use short division to divide by 7, again we get a number that doesn't have a remainder. So 378 is a common multiple of 3 and 7. It's a multiple of both numbers. If we were to count up in threes 126 times, we would get to 378, and if we were to count up in sevens 54 times, we would get to 378 as well. On a school trip, every child is given 2 apples and 5 cherries. Mrs. Smith gives her group 12 apples. How many cherries does she give her group? So we know that every child gets 2 apples and 5 cherries, but Mrs. Smith gives out 12 apples, so we can write that below. Now we need to think 2 times what is 12? Well, 2 times 6 is 12, so Mrs. Smith must have 6 children in her group. So to find out how many cherries she gives out, we can multiply by the same, so multiply by 6, and 5 times 6 is 30, so Mrs. Smith gives out 30 cherries to her group. Tick all the numbers that are equivalent to 13 hundredths. So we have decimals here, and we know that the second digit after the decimal point tells us how many hundredths we have. So as a decimal, we write 13 hundredths as 0.13, because the second digit is the hundredths digit, but because we can only have one digit in each place value, the 1 from 13 gets moved over into the tenths. Remember, the tenths digit is the first digit after the decimal point. So 0.13 is the same as 13 hundredths. But the question says tick all the numbers. It doesn't say tick the number, so that's a clue that there will be another correct answer as well. Now with decimals, we can write a 0 or zeros on the end without changing the number. And we can do that because 0.130 is the same as 0.13. All this 0 on the end tells us is that we don't have any extra thousandths, because remember, the third digit after the decimal point is the thousandths digit. So 0.130 is correct as well. A torch costs £7.65. Kate buys a torch and 2 batteries. She pays £8.75 altogether. How much does 1 battery cost? Well, first of all, let's work out how much money Kate spent on 2 batteries. We know that she paid £8.75, but £7.65 of that was for a torch. So if we subtract £7.65 from £8.75, that gives us £1.10. So she spent £1.10 on 2 batteries, but we need to know the cost of 1 battery. So we need to divide by 2. £1.10 divided by 2 is £0.55 or 55 pence. And here we might need to use column subtraction and then short division to get our answer, but we get 55 pence. How many quarters are there in 2 3/4? So here we have a mixed number because we have a whole number and a fraction. But if we change that to an improper fraction, then the numerator will give us our answer. So we have 2 3/4. To get the numerator of our improper fraction, we need to work out 2 times 4 plus 3. So we need to multiply the whole number by the denominator and then add the numerator. 2 times 4 is 8, and 8 plus 3 is 11. So as an improper fraction, we write 2 3/4 as 11 quarters. So as the question asks, how many quarters are there? We know that we have 11 quarters. Circle the fractions that are equal to 80%. So percentages are fractions with a denominator of 100. So 80% is the same as 80 hundredths. But the question says circle the fractions with an S on the end. So some of these fractions here will need to be circled as well. So will also be equal to 80%. Now what we can do is find equivalent fractions. So if we simplify 80 hundredths, we can divide both the numerator and the denominator by 10, and that gives us 8 over 10, or 8 tenths. So that's equal to 80% as well. And if we simplify further, 8 and 10 are both in the 2 times table, so we can divide both the numerator and the denominator by 2, and that gives us 4 over 5, or 4 fifths. Now our other fractions are 1 over 80, which is very small, and 8 over 80, but we know that that can't be right because we found an equivalent fraction with 8 over 10.